Hi, good morning everyone. Today we've got a differentiating problem that needs us to find the rate of change of a camera's angle as a function of time so that it stays focused on the rocket. Now here we've got a diagram that shows everything we've said. We have a camera which is 6,000 meters away from the launching pad, and we've got a rocket which rises vertically. So to find the function, like rate function of change, we'll take tan theta as a subject. We'll say that tan theta equals to opposite over adjacent. It will be h over 6,000. Now we take h as a subject, we'll get 6,000 times by tan theta. Now to get the rate of change, we need to derive it implicitly with respect to t. We'll get dh over dt equals to 6,000 times by secant squared, which is the derivative of tan theta, times by d theta over dt.
Okay, so we need to find the value of d theta dt as mentioned in the question. So in order to get this value, we need to find the value of 6 squared theta. And we already know the value of dh dt, which is 200 meters per second, and we got that from the question here. The velocity is 200 meters per second. And at that point of time, the rocket is 500 meters above the launch pad. So we can draw a small diagram to represent that position of the rocket. So here we have the hypotenuse as c. So in order to get c, we need to use Pythagoras theorem. So c squared is equal to the root of 6,000 squared plus 500 squared. And we get the value of c. And you can also get the value of secant theta from this diagram. So as we know, cosine theta is equal to the adjacent over hypotenuse. So 6,000 over c. And we also know that sec theta is the reciprocal of cosine theta. So sec theta is equal to c over 6,000. Using this value of c that we calculated, we can find sec squared theta. So 6,020.8 over 6,000 squared, and we get this value. So now we have all the values. Now plugging these values into the equation that we derived, we get 200 is equal to 6,000 multiplied by 1.0069, which is the value of 6 squared theta, multiplied by d theta dt. So plugging all these values into the calculator, we get the value of d theta dt to be 0.0331 radians per second. So this is the rate of change of the camera's angle.
Hello, today me and my friend are going to be solving this integral question, and we're going to show you the solution step by step. A mechanical engineer is designing a solid piston for use in hydraulic system. The height of the piston is 10 centimeters long, and its radius varies with the distance. We have here the formula stated: R of x equals 1 plus x over 5. Which R represent the radius of the piston and X represent the distance from the flat base of the piston, both measured in centimeters. We should find the total volume of the piston in centimeters cubed. We have here the formula stated is R of X equals 1 plus X over 5. And to solve this question, we're going to use this method, which is V equals pi multiplied by the integral of R of X squared, using the intervals 10 to 0. You may ask me why we use the 10 to 0 intervals, because here the distance is 10 centimeters long, and here it is stated in the question that the radius varies with the distance from when and occurring. We have here B equals pi and the integral of 1 plus x over 5 squared using the intervals 10 and 0. Now we're going to need to expand this bracket in order to make it easier for us. We're going to expand it, of course, with respect to x. We have here the squared, this bracket squared is equal to 1 plus 2x over 5 plus x squared over 25. You may ask me how you get it. We have here the formula of bracket a plus b all squared. It's gonna be a squared plus 2ab plus b squared. That's how we got it.
After we expanded this equation, we will integrate each term separately. The integrate of 1, which is give me x, plus in the integration of 2x divided by 5, will give me x squared divided by 5, plus the integration of x squared divided by 25, which is x cube divided by 75. The interval from 0 to 10. Then the answer will give me by multiply 10 plus by 10 squared divided by 5 plus by 10 cube divided by 75. After I add all of these terms, I will get 130 by divided by 30, which is 136.14 centimeter cube.